Welcome to MRL. This is the second part of the study of a pair of linear equations in two variables. In this part, we'll understand how to identify the type of solutions of a pair of linear equations. Now, there are two different methods of identifying the type of solutions of a pair of linear equations. The first method is on the basis of ratios of the coefficients of a pair of linear equations in two variables. If a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0 are a pair of linear equations, then the ratio of a1 upon a2, that means taking the ratio of the coefficients of x, that is a1 upon a2, and the ratio of the coefficients of y, that is b1 upon b2, and if we find that the two ratios are not equal, that is a1 upon a2 is not equal to b1 upon b2, then the equations have unique solutions. The equations have unique solutions, means the only one value of x and y satisfy both the equations. Remember that. Now, the second possibility is that the two ratios, that is a1 upon a2 is equal to b1 upon b2. The coefficients of x, a1 upon a2, the ratio of that a1 upon a2, and the coefficients of y, b1 upon b2, both are equal. And if these two ratios are equal but not equal to c1 upon c2, that is the ratio of the constants c1 and c2, if I take these three ratios, if a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, then the two given equations have no solutions. Remember that. Now, the equations will have infinite solutions if you take the three ratios, that is a1 upon a2, b1 upon b2, and c1 upon c2. If all the three are equal, then the two equations will have infinite solutions. That is how we find out or identify the type of solutions of a pair of linear equations in two variables by taking the ratios of the coefficients of x and y and the ratio of the constant. Then there are three possibilities by which we can understand or identify whether the solutions are unique, infinite, or have no solutions. Now, on the basis of graphs of equations. Now, this is based on the method that we draw the graphs of the two straight lines. That we draw the graphs of the two equations. As we know, the graphs of the two equations are straight lines, and if the graphs drawn, they intersect at a point, in one particular point. If the lines intersect, then the equations have what we call unique solution. The equations have unique solutions. The equations are consistent. One value of x and y satisfy both the equations. The coordinates of the point of intersection give the values of x and y. So this point of intersection P gives the value of x and y, which satisfy both the equations a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, and that is the first possibility. Now, if the graphs are drawn, the two straight lines of the two pair of the given pair of linear equations are parallel. That means the two straight lines are parallel lines. Then the equations have no solution because there is no common point between them. Therefore, they have no solution. The equations are said to be inconsistent. And the third possibility is if the lines are coincident. If we draw the graph and the two straight lines coincide with each other, then the solutions of the equations are infinite solutions. Therefore, the equations are consistent and also dependent. That means they have infinite solutions, they are consistent, and also they are dependent. Every point on the coincident line represents the solutions of the equations. Remember that.